It just may pick up your voice if you answer. All right, so today we're looking at solving equations. So first of all, our vocab says the solution to an equation is any number that makes the equation true. And you may remember that sometimes an equation can have a no solution, meaning there's no number that can be plugged in. Or it can also be called an identity, which is if any number works with be plugged in. So for example, this would be called an identity, because if we were to distribute on this side, you end up getting the same exact equation on both sides, so no matter what number you plug in, it would remain true. That's called an identity. The no solution occurs when there's actually no number that can be plugged in to solve. And I can't think of one of those just off the top of my head. Sorry. And then here are just a review of some of the properties of equality. Properties of equality say that you can use that property on both sides of the equation to balance. So if you see +2, you can do -2 on both sides. So all these properties you're pretty familiar with. The only ones that you might forget are these ones. We don't really use them that much, but these were geometry properties too. The reflexive property just tells you like something is equal to itself. 2 is equal to 2, x is equal to x. The symmetric property allows you to switch them. So the most useful one is if you were to get 2 equals x as like the end. You know, most of your algebra teachers would make you flip that around and make it x equals 2. That is the symmetric property. And then the transitive property we always call it the train problem, because it's like connecting one to the other. So if A is equal to B and B is equal to C, then you can connect A straight to C. They would have to be equal. And then all of the remainder properties are going to be used in solving equations. So I would actually like you guys to solve both of these as a warm-up. And then we'll pair share. You should already know how to solve these. So today we're going to make them a little bit more difficult. We're going to see a lot of variables and less numbers. The properties that you just used will follow the same idea. You're still going to isolate that variable by using inverse operations. So I'll start off with a couple easy ones, and then I'm going to add an example D. So it says solve each equation for x. Okay, so sometimes it'll help if you highlight or circle x and just realize that that's what you want to stay where it's at and move everything else to the other side. So what should I do to both sides to solve for x? I haven't heard from. How can I move the -5 over? Marley? Add 5. The inverse of subtraction is addition. So we get x equals, now can I add the y and 5 together and get 5y? No, those are not like terms, so we'll just leave it. Y plus 5. That's right. Example B, also solving for x. Max?
Divide 7 out of 7 with x.
Perfect. We see multiplication. The inverse is division. So x equals a divided by 7, or you could also write x equals 1/7 a. Those are equivalent. I don't care which one you do. And how about C? Julia?
Multiply 3.
Multiply by 3. Right now we see x divided by 3. The inverse of division is multiplication. Now let me add a little d. 2. What did I have? 5x plus y equals z. Let's add that to your paper. 5x plus y equals z. So again, maybe circle or draw attention to your x. This is going to be a 2-step. So it's going to take 2 inverse operations to move everything to the other side. What should I do first? Max? I would not. The only reason is, it's not wrong, but if you have to divide by 5, you would divide this by 5, this by 5, and this by 5. So you'd end up with y over 5 and z over 5. It's a little bit more messy than if we were to do something else first. Yeah, Gio is right. I would subtract y first. So then we have 5x equals, again, you cannot combine these, just leave it z minus y. And now max I would divide by 5. And that way you don't have to worry about finding a common denominator and moving fractions around. Just a little bit easier. So our answer is z minus y, all divided by 5. Not hard, right? It's the same thing you did with numbers, but just looked weird, because there's all variables. Okay? Below, we have a bunch of formulas, which again, some of you will remember from geometry. We're going to solve for an indicated variable. So the first one, does anyone remember what that formula is for? Brett? Area of what? What shape? Jack? A triangle, 1/2 EH, very good. You don't have to know that to be successful in the class, but I just try to review as we go some geometry stuff. So if you haven't taken geometry, it's okay. This one we're solving for B. So I'm gonna circle my B or highlight it just to make it stand out. I wanna leave B where it's at, so I need to move the 1/2 over and the H over. So what should I do to move those around? What operations do we see going on between those things? Multiplication, right? This is 1/2 times B times H, and we want to solve for B. So to undo multiplication, we use division. Now, it's not proper to divide by a fraction. So I know some students will say divide by 1/2. But that's, again, not proper. You're going to get a fraction within a fraction. So instead of dividing, what can you do instead? Olivia? Or it's Kelsey, sorry. Multiply by its reciprocal, which is 2. Whatever you do to one side, you have to do to the other side. So the 2's undo one another on that side, and we're left with now 2a equals b times h. Again, I always circle the variable that I want to solve for because it's so easy to get confused with all the letters and start solving for h instead of b. So now we can undo multiplication again with division. Divide both sides by h. To save myself a line of work, I'm also going to use the symmetric property, and I'm going to flip that around so that I have b on the left. So b is equal to 2 times the area divided by the height. The next one, does anyone remember what this formula stands for? Right again?
Circumference of a circle.
Circumference of the circle, which is like the perimeter of a circle, basically, distance around it. Similar property we see multiplication. 2 times pi times the radius. And they want me to solve for the radius. So what will I do to both sides? What operation do I see? What's the inverse of that operation? Margaret?
Divide by 2 pi.
Good. You can divide by 2 and pi at the same time. You can do it separately, but since everything's being multiplied, you can divide it all at the same time. These will divide out, and I'll flip that around so that I have r on the left. Radius equals circumference divided by 2 pi. Excellent. Now C is going to be a little bit harder because we have probably more than one step. They want us to solve for L. So in this case, I see multiplication and addition. Just like if you're solving a regular equation with numbers, you would subtract the 1 first, right? And then divide by 2. So the same thing is going to go up here. If I want to solve for 2L, I'm going to leave this where it's at. I'm going to move the 2W over. So I see plus 2W, the inverse is minus 2W. So I have P minus 2W equals 2L. And then last thing would be 2. Right? Divided by 2. Now be careful. This whole thing needs to be divided by 2. Some students will just cross these off, but technically P has to be divided by 2 and 2L has to, or 2W has to be divided by 2. So you can either leave it like that, the way it is, or if you want, you can split it up to make it P over 2 minus, then the 2's would cancel to be W. One or the other, I don't care which one, just make sure you don't cross those out, make it P minus W, because that would be incorrect, since both things are being divided by 2. Alright, so those were the easy ones. Now we'll get into some harder ones, and there's a reason that I put factoring on your summer packet, because we're going to be using factoring in some of these problems. So this one is the area of a trapezoid, for those of you that remember geometry a little bit. H is the height, which is always a perpendicular distance. B1 and B2 are the bases. Those are always parallel to each other, and we're looking for the area. So this one we want to solve for B1. Now, I can't tell you how many of you will start distributing, because that's what we normally do is the distributive property. But you don't actually want to distribute this because we want to get the half and the h over and the b2 over. You want to leave the b1 where it's at. So distributing would actually be counterproductive because then you're going to have to undistribute later. So I wouldn't do that. Maybe make a note of that. So just like we did on the front with the 1/2 BH, how can I move the 1/2 to the other side? Someone I haven't heard from today. Caleb?
Multiply by 2.
Good. Multiply by 2, which is its reciprocal. So I'm going to have 2a equals h times the quantity b1 plus b2. Again, don't distribute. It's a hard habit to break because you want to. You're so used to it. But then you're just going to have more h's, and we really don't want that. So now let's move the h over before distributing it. So what should I do to both sides to get h on the left-hand side? What operation, Dan?
Divide.
Good. We see multiplication between these two things. The inverse is division. Always ask yourself that question. What operation do I see? What's its opposite? You now can drop off the parentheses because there's nothing else over there with them. And lastly, if we're solving for b1, I need to undo addition with subtraction. So there's two ways you can write your answer. You can either have 2a over h and then minus b2 at the end. Do not put it all over h because it's not. If you wanted to write it as one whole fraction, you would then need to make this have a denominator of h, which would be 2a minus hb2 all over h. I don't recommend that, but it is the equivalent form. I would prefer what I have in purple there. All right, our last one. You guys might have some time for your homework today. How lucky. This is the hardest one, so put some stars here. Let's not lose our attention span at the end of class. So, in the last two examples, whatever variable we were solving for, I said circle it. Okay? Now in this case, we're going to notice something a little bit different. We want to solve for w. So if I go and circle w, you're going to notice we have two of them. Okay? Anytime you see that you have two of the variable that you want to solve for, that's going to indicate that you're probably going to have to factor at some point. And it's not even the hard factoring from your summer pie quiz, it's just going to be a GCF of a W. But right now you can't take that out until we get some stuff moved around. Let's first move the 2 over. How do I move the 2 over? Someone I haven't heard from. This is an easy question for you to volunteer answer. Katie?
Divide.
Divide. Thank you. Now we don't need the parentheses on the right-hand side anymore, so let's just drop those off. We have LW plus LH plus WH. And again, I'm going to circle the variables that I want to solve for. I want to solve for the W. Because again, this gets real confusing when you start having all these letters. So we want to leave the W's where they're at for right now. We want to move over what doesn't have a W in it. So the LH, how can I move the LH to the other side? Subtract. So we have, and you can leave it A2 or you can make it 1/2 A if you prefer, it doesn't matter. So again, I want to solve for W, but I have 2 of them showing up. So at this point, we are going to factor out a GCF. We could not do it before because not all of them had W's, but once we've moved some of the stuff over, now you can see that they both have a W in common. And again, when you factor that GCF out, you're essentially dividing by W and putting it outside of a set of parentheses. So I'm not moving anything over yet, I'm just simplifying on my right-hand side. I would be left with W on the outside, and then L plus H on the inside. Double check, redistribute. W times L is LW, W times H is WH. So I haven't changed the value, I'm just changing the way it looks. Let me move my box here. So now the last step, second to last step I guess, is to undo this operation. We see multiplication, we're going to divide. You're going to divide by this whole parenthesis set, which looks weird. Do not redistribute because you're undoing what you just did. Now over here we're going to have to clean this up a little bit. So the answer that I've got is A divided by 2 minus LH all over L plus H. And you can put parentheses around that if you'd like. Don't need them though, because of the big fraction bar. Now it's usually not common to have a fraction in a fraction. Those are called complex fractions. So we actually kind of need to get rid of that denominator. So, to do that, if I want to get rid of this 2, I can multiply the top by its reciprocal, 2, over 1. But whatever you do to the top, you also have to do to the bottom, just to balance. Just like if you had 1/2 and you multiplied by 2, you would get 2/4, which is still 1/2. So we have to multiply both of those by 2. Dan?
Do you think that at the end you can go back and start from where you divided that by the parentheses? Yeah, from there.
Right here?
Yeah.
All I did was flip that around. Or do you want me to go back to this part?
Yeah.
Okay, so we were at this part, we had our W's, that's what we're solving for. We can't have 2 of them, you can only have 1.
Yeah.
So I factored a W out, I pulled out a W from each one, and I was left with L plus H. Okay, you do not want to redistribute it, or else you're going right back to where we were. So then we look and we say, what operation do we see? I see W times L plus H. What's the inverse of multiplication, Dan?
Divided.
Okay, so we divided by this whole quantity, L plus H.
Yeah.
That's your answer, we just need to clean it up. So all I did from here was copy that over there, I flipped it around, so we have W on the left, A over 2 minus LH over L plus H. That's basically your answer, it's just not simplified.
Okay. Yeah.
Okay, because we can't have this 2 in the bottom, that's the only problem. So I'm multiplying the top by 2 and the bottom by 2. Again, you will need to distribute, because both of these things, if you see a plus or a minus, that's indicating that you have your distributive property. So in the first case, you would get 2A over 2, which the 2's would cancel, you're just left with A. When I distribute the 2 to the LH, I'll have minus 2LH. And then in the bottom, we would need to distribute the 2 as well, and we would get 2L plus 2H. That's our final answer. If you were to get to this part and not to there, you'd probably lose like a half point or a point, depending on how many points the question were, just for not simplifying, but getting the hard part of the concept out. All right, I'd like you guys to try your closure, which is an area of a circle formula. Because this is the side that most of you will have the most trouble with. This is grayed out side. So we'll just start with the first one. 42. They want you to solve this for capital R. So again, on your homework, you want to go circle, use a highlighter, something, like draw attention to what you want to solve for. Do not distribute the R, because then you're going to have 2 of them. And then you're going to have to factor it. So since you have just one capital R, leave it the way it is. What operation do I see going on between capital R and the parentheses? What operation is hiding right here? Kayla? Multiplication. And Kayla, what is the inverse of multiplication? Division. So all you need to do is divide. Undo these 2 things multiplied and divide. You're going to divide by the whole quantity, R1 plus R2. Those subscripts they're not coefficients or anything, they're just telling you which radius you're talking about. So those undo one another, and you're done. That's it. Looks crazy. Same thing that you do with numbers all the time. Alright, 43 is the hardest one. I'm not going to do it. I want you to try it. We are in an honors class. Let's go to 44. So 44 is this equation. They want us to solve for h. There's only one of them. Makes it easier. What should I do first? I want to leave the h where it's at. I need to move everything over to the other side using inverse operations. Who thinks they know what I would do first? Brett?
Divide by 2 pi.
You could, if you wanted to. Because each of these have the 2 pi. That's not what I would do first, but you can. Kayla?
Subtract not 2 pi r squared.
Yes, we would want to move this over. Like if this said 5 plus something, you would know that the inverse of adding 5 is subtracting 5. This just happens to have variables and numbers and pi's in them. So we're undo addition with subtraction. So s minus 2 pi r squared equals 2 pi rh. And now we just need to get the h alone. So what will I do to both sides? Yeah? Divide by 2. Yes. You also need to divide by a pi and an r. So you may as well just do them all together. Since it's 2 times pi times r times h, you can undo all of them at the same time. The only number that or variable that you want to leave over there is your h. You cannot cancel the 2's because the top is what's considered a binomial. It's 2 things being subtracted. So you cannot cancel anything out. Our answer is then just h equals s minus 2 pi r squared over 2 pi r. All right, we'll call it a day at that point.